Welcome to aminacademy.com. In engineering thermodynamics, let us discuss about reversible temperature, that is isothermal process and reversible adiabatic process. First, we will discuss about isothermal process. A process at a constant temperature is called a isothermal process. When a working substance in a cylinder behind a piston expands from high pressure to a low pressure, there is a tendency for the temperature to fall. In an isothermal expansion, heat must be added continuously in order to keep the temperature at the initial value. Similarly, in an isothermal compression, heat must be removed from the working substance continuously during the process. Now, look at here. This process 1 to 2, it expands like from V2 to V1. The temperature that is from volume V2 to volume V1. The constant temperature processes are referred to a isothermal process. There are a number of isothermal processes encountered in a common usage. Boiling and condensing process occur at constant temperature and are accompanied by a change of phase of the working fluid. Now we will discuss further about the formula. Considering the unit mass of working substance and applying the first law of thermodynamics, we can say Q, heat added, equal U2 minus U1 plus W, internal energy plus work done, which is equal U2 minus U1 is CV, T2 minus T1, work done, W, here which is 0 because T2 equal to T1. Therefore, CV T2 minus T1 is 0 plus W. That means Q equal work done. When Q equal to work done, we can write as integral 1 to 2 P dV. In this case, PV equal to constant. Then look at here, P equal to constant, you can say, then P equal to C, then we can say P equal to constant C by V. We apply this here, therefore Q equal integral 1 to 2, instead of P you can write C over V dV. Now, therefore, that Q, that is work done here, instead of Q equal to W, we can write W here. Therefore, W is integral V1 to V2. Integral path 1 to 2 gives V1 to V2 in terms of V we are writing. Here C dV by V. That means we are writing P equal to C by V and dV. Now, by integrating, we will get this is the constant logarithm 1 by V is V2 by V1. Therefore, work done you can write as C log V2 by V1. Here, we can consider that constant C can either be written as P1 V1 or P2 V2. Now we know that continuous process P1 V1 equal to P2 V2, that is equal constant C. Therefore, W is the constant C, you can write P1 V1 log base E V2 by V1 per unit mass of the substance. Then also we can write W equal P2 V2 log E V2 by V1. Same per unit mass. Therefore, we can write Q equal to W equal P1 V1 log E V2 by V1. Now here general law P1 V1 by T1 P2 V2 by T2. Here entities equal. So we can write V2 by V1 equal P1 by P2. Therefore, Q equal, instead of that we can write is V1 log the V2 by V1 is in terms of P1 by P2 you can write. P1 by P2. This is a expression for constant temperature process. Now next one we'll talk about reversible adiabatic process. An adiabatic process is one in which no heat is transferred to or from the fluid during the process. Such a process can be reversible or irreversible. The reversible adiabatic non-flow process will be considered in this section. Now, an adiabatic process is defined as the thermodynamic process in which there is no exchange of heat from the system to its surroundings, neither during expansion nor during compression. Further, we will discuss Q for unit mass. Q heat added is equal internal change in internal energy plus W. W, therefore we can say zero because no heat added to the surroundings or go out of the surroundings. That is U2 minus U1 plus W. Therefore, from here we can write W equal to U1 minus U2. Here, this is true for adiabatic process, whether the process is reversible or not. Now we derive the law. Let us derive the law PV power gamma equal to constant. Let us derive this. Now dq equal to change in internal energy du plus dw. For reversible process, dw equal pdv, and therefore dq you can write as du plus dw is pdv, because you are substituting dw equal to pdv here. Then for adiabatic process, q equal to 0, therefore you can write du equal therefore now for a perfect gas, we know the relation PV equal to RT, or you can say P equal RT over V. Then we can say dq equal du here. PdV is we can write as RT by V into dV, which is equal to 0 because dq equal to 0. Then divide both sides by T. Therefore, you can write here du plus RT by V dV equal to 0. Divide throughout by T. We have CV before that. Then U equal CVT or du equal to CV dt. Then we have to, therefore you can say CV dt plus RT dV by V equal to 0. We are substituting here. This du, change in internal energy, is CV dt. That's relation here. Then dividing throughout by T, we can get it CV dt by T plus R RT dV by V T. Then T cut. Therefore, you can write CV dt by T plus R dV by V is equal to constant. Now integrating we get, that is CV dt by, that is integrating CV dt by T plus integrating R dV by V constant. Then you can say it is equal, CV is the constant out of integration, dt by T is log T plus R is a constant, take out of integration, and dV by V is log V, which is constant. Then substituting T equal PV by R. P equal to T, that relation we can get T equal to PV by R. Therefore, you can say then CV log T, instead of T you can write PV by R. PV by R plus R by R log E R log E V equal constant. constant. Here we know that, again look at here, we know the relation CV equal R by gamma minus 1 or R by CV equal gamma minus 1. We have the relation here where gamma equal to Cp by Cv, where gamma is the index, Cp by Cv. Now, hence substituting, look at here, substituting these things here, log E PV by R plus here R log EV gamma minus 1 into log EV equal to constant. Now here addition of log, before that look at here, log E PV by R plus this gamma minus 1 is multiple of log EV, that it go as a power, that is log EV gamma minus 1 is equal to constant. Then addition of logs here, log of is multiple of these two things, PV by R into V gamma minus 1 is a constant. Then log E, here V power gamma minus 1, both multiply becomes the minus 1 will go V power gamma. Therefore, V e power gamma over R is constant. Then here e power log of e power something, log of something base E equal constant means taking E both side, which is equal PV power gamma over R is e power that constant. Because this log E removed by e power. If we take this log as normal, we can get it P V power gamma over R is e power constant. Therefore, e power constant is also a constant. Therefore, PV power gamma over R is equal constant. This is the main expression for adiabatic process. Now, expression for work done. Work done in adiabatic process. Look at here. Here, W equal integral V1 to V2 PdV, we know that. And PV power gamma equal to constant C. Therefore, we can write W equal integral V1 to V2 C dV by V power gamma, because we have the relations before V power gamma equal to constant, and that therefore work done equal C out of integration V1 to V2 dV by V over gamma, which is equal C into here integral of dV over V power gamma. Know that V minus gamma plus 1 over minus gamma plus 1 raising the power, which is equal C applying V1 and V2 the limits, we can get it V2 minus gamma or minus 1 plus 1 minus V1 minus gamma plus 1 over 1 minus gamma, and further it is equal C into simplifying this we can reverse, that is multiplying minus, it becomes V1 minus gamma plus 1 minus V2 minus gamma plus 1 over gamma minus 1. Always gamma is greater than 1. Now the constant in this equation can be written as constant C. Therefore constant in this process is equal V1 for gamma or V2 for gamma. In that, therefore, substitute the constant values, we can get it V1 for gamma into V1 minus gamma plus 1, that is you are substituting the constant C here. Then V2 then V2 minus gamma plus 1, both here gamma minus 1, gamma minus 1. Therefore, by simplifying, we get here this gamma V1 power gamma, V1 power minus gamma will cut. So we have V1. Here V2 power 1, V2 power minus gamma plus 1 becomes V2. That is V2 over gamma minus 1. Therefore, work done is here. Then relations next is we can get it the relations between temperature, volume and pressure. We know that PV equal to RT. In that P equal to RT by V. By putting these values in PV power gamma equal to constant, now we have PV power gamma equal to constant. Then putting this value above RT by V. RT by V equal to P. That is P equal to RT. Putting this value in the equation P power gamma, then RT by V, that is P into V power gamma equal to constant because PV power gamma equal to constant. Then RT by V equal temperature T. Then RT by V. Then we here this V and this V power gamma becomes V power gamma minus 1. Therefore, you can say T V power gamma minus 1 equal to constant. Also, we have the relation V equal to RT by P. Then, hence substituting this equation, PV for gamma equal to constant in this, you can write RT by V into V power gamma, that is PV power gamma, equal constant, then P into, now before that, here V equal RT by P, P equal to RT, in that you can substitute, therefore P into RT power P power gamma equal constant. P power gamma equal constant because we are substituting here. Then therefore you can say which is equal T power gamma by P power gamma minus 1 equal to constant. Therefore you can write T over P power gamma minus 1 over gamma equal to constant. Therefore, now by using these relations, we have finally now this is in general T over P power gamma minus 1 to another process T1 and T2 you can write it. Therefore, from this we can write T2 by T1 equal P2 by P1 power gamma minus 1 power gamma. From this, previously we discussed that work done in this process. We can write P1 V1 by P2 V2 by gamma minus 1. So far we discussed little difficult derivation for adiabatic process, that is work done. Also we discussed about isothermal process also. We have done. Please subscribe our YouTube channel.